Hello, this is Mr. Muller for lesson 10-5, experimental probability. So it's kind of a fun lesson. We'll talk about probability with math and then kind of like with games and things like that. So hopefully, if you're one of those people like Mr. Muller that thinks about things with like Connect 4 or Clue or things like that, games like that, this will probably make you a better game player, even with sports of, a team's down by 4. What's the probability they're going to go for a 3-pointer or a 2-pointer in basketball? Things like that. What should they go for? So that's where all that probability and things come in the hand with all those percentages. Okay, there's some vocab that we kind of need to know before so we know what we're talking about. So what an experiment is, what a trial is, what an outcome is, what a sample space is, what an event is, what probability is, what's the difference between probability and experimental probability, and what our prediction is. Okay, so experiment, so the outcome that can be used, so basically what's going on. And then a trial is a single repetition or observation of the experiment. So trial just usually means one time. So usually a trial is not the best way to do it. If I flip a coin one time and I get heads, it doesn't mean I'm always going to get heads. I need more of an experiment than a trial to figure out what that's going to be. So outcome, what my two possible outcomes will be if I'm flipping a coin, heads or tails. Sample space, the rest of the outcomes, like rolling a dice, 1, 2, 3, 4, 5, or 6. And then event is the number or the outcome for this, an outcome or set of outcomes for the experiment. And then probability, how likely to occur it is. And then there it is. So experimental probability, so the ratio of times it occurs versus the number of trials. So what actually happens, not what we think is going to happen. And then our prediction is, of what we guess. And there's kind of a little map here. So something that's, impossible to happen versus unlikely to happen, as likely as not. So about a 50-50 shot, likely or certain. Okay. So if I have something like this, rolling a number cube, I can have 6 different options. If I'm spinning a spinner, there's 4 options on the spinner, so I could have 4 different options. If I have something like this, an experiment consists of spinning a spinner, use the results, finding the experimental probability of what happened. So it could be this spinner right here where there's only 4 colors, but, if I spin it 5 times, there's going to be one color that at least lands twice. So kind of here. So if I spun it and I have 15, and then 10, and then 8, and then 7, well, the first thing I usually want to do is figure out how many times it got spun. So if I have 15 and 15 is 30, 30 and 10 is going to give me 40. So I spun this spinner 40 times. Probability of it landing on orange, well, that was 10 out of 40, or 1 out of 4 times, which is pretty accurate because I would expect it to land on orange 1 out of every 4 spins because there's 4 colors. So that means not landing on orange, that would be 30 out of 40 times, or 3 out of 4. And then not landing on green would be, so it did land on green 15 times, so it did not land on green 25 out of 40 times. Or we can even simplify that by 5 and do 5 out of 8 times it did not land on green. So sometimes with probability it helps to figure out what didn't happen to help figure out what did happen. It's kind of weird to think like that, but kind of like with crossing out answers on tests, well, if you know it's not A or B, well, that increases your probability. Or something with experimental probability, and this is true with today and kind of sad depending on how you look at it. So if a manufacturer inspects 500 strollers and finds 498 have no defects, that means 2 of them did. So, you don't know what's going to happen with those 2, but that means 2 of them have defects. So what is the experimental probability that a random stroller has no defects? So that's going to be 498 out of 500, which should be a pretty high percent. Let me grab my calculator. So I have 498 out of 500 is 99.6%. So that means 99.6% of them are going to have no defects. Okay, and if 3,500 strollers are shipped, predict the number of strollers that are likely to have no defects. Well, if I have 498 out of 500 have no defects, and I'm dealing with 3,500 now, to get from 500 to 3,500, I would have to multiply by 7. So to multiply 498 by 7, I would end up with 3,486 would have no defects. So again, now when we're talking about that many strollers, now it looks like 14 of them are going to have something wrong with them.